7.3 says, for which values of x will the tangent to f of x have a positive gradient? So for which values of x will this have a positive gradient? When we deal with gradient, we do the first derivative. So getting the first derivative first, we get minus 6 from minus 2 times 3 to the power of 2, 3 minus 1, plus 8, which is just a constant. So for it to have a positive gradient, we need this. Remember, the first derivative represents the gradient of the original function. Therefore, in order for the gradient to be positive, we need it to be greater than 0. Therefore, it's just minus 6x squared plus 8 is greater than 0. For which x values will this be true? So at this point, we need our critical values. So we can say, let's make it easy and have 8 go to the other side and then divide by 6 or by minus 6. So if we do that, we're going to have x squared is smaller than 8 over 6. And then we get our critical values. Remember, critical values, we get it basically what would normally have been the answer, like this. Our answer would have just been plus minus root of 8 over 6, right? But now, what normally would have been our answer is now our critical values. So that would be the square root of this and that. The square root of this, positive and negative. So it will be minus 2 over root 3 if you use your calculator, or it will be 2 over root 3. So again, no difference. We draw our x-axis. We indicate our points, minus 2 over root 3, and we indicate our other point, 2 over root 3. And we're looking for the region. Remember, over here we divided by negative, so the sign changed from greater than to smaller than. Therefore, we're looking for an answer within this region. So when we write our answer for which x values will this be true, it will only be true for the answers between minus 2 over root 3 and 2 over root 3, like that. So that is the range of values for x that will allow this function to have a positive gradient, or for which this function has a positive gradient.